Hello everyone. We have discussed different types of vectors. Many types we have discussed in the previous video. Now in this video we are going to discuss zero vector, or it is also known as null vector. Now this vector, which is zero vector or null vector, has a zero magnitude, but it has an arbitrary direction. So let us discuss about that vector. So in this video we are just going to discuss the zero vector or the null vector along with its properties also. So first of all, what is a zero vector? A zero or null vector is a vector that has zero magnitude and an arbitrary direction. Now you need to understand a vector which has a zero magnitude. So it doesn't have any magnitude, but it has an arbitrary direction, so that being zero, it still remains a vector. Okay? It is a vector having zero magnitude but an arbitrary direction. Arbitrary direction means it is a vector. So that's why we are putting some direction to it. It is represented by 0 with an arrow over it. Okay. Now, why do we need a zero vector? There are some situations where we need a zero vector. Suppose two vectors like vector A and vector B, they are equal vectors. Then if we want to subtract one vector from the other, that is vector A minus vector B or vector B minus vector A, so the result naturally will be 0, but since we are considering two vectors, the answer also has to be a vector quantity. That's why we need a zero vector. Take another example. In this situation, you see mu is equal to minus lambda. Then suppose we have an equation which has lambda plus mu into vector A. So if we consider this situation, then we know that lambda and mu are having negative values. Mu, if we write it as minus lambda, so the magnitude here becomes 0. Lekin it has a direction here, and which is the direction of vector A. So the answer will be having a magnitude 0, but they will have a direction. So we need a zero vector here. So these are the situations where we actually need zero vector. You can see here the resultant has to be a vanishingly vector, that is zero vector, and not a scalar, because we need the direction also, because in the question suppose it is vector A minus vector B, so it is a vector quantity. We need the answer in vector. Here lambda plus mu into vector A, the answer should be in vector, but the magnitude should be in 0 in both the cases. Hence there is a need for introduction of the concept of zero vector. Okay. Now some of the properties of these zero vector that we are going to discuss. The first property, any vector added with zero vector will be the vector itself. Okay. Next, suppose we have a zero vector and we multiply it by a real number. Suppose it is given by lambda. The answer will be the zero vector. Okay. Then the next property is, if we multiply 0 with a vector, then the magnitude becomes 0 and it has an arbitrary direction, so it is represented by zero vector. So 0 multiplied by a vector is a zero vector. And the last property that we are going to discuss here, suppose lambda and mu are two different non-zero real numbers. They are different and they are non-zero real numbers, and we have a relation in which lambda vector A is equal to mu vector B. So these two, the left hand side and right hand side, you can see there lambda vector A is equal to mu vector B. Now this situation is only possible if vector A and vector B both are zero vectors. because we are already given that lambda and mu have different values. So naturally these two values can be equal only if lambda into vector A is equal to mu into vector B, where vector A and vector B are the zero vectors. So I hope you understand properly what is zero vector, and these are the properties of the zero vector. But still then, if you have any doubt, you can post me the doubts. Thank you.